In this lecture, we'll work out some numericals on polynomial arithmetic and we'll find out multiplicative inverse of the given polynomial. So the question here is, for an GF of 5 on the set Z5 where 5 is a prime with the addition and multiplication operators, we have to find the values for addition, multiplication operators, additive inverse and multiplicative inverse. So first let us write a table for addition. So here plus I will write, then we have numbers from 0 to 5. So here GF of 5 means the set contains 0, 1, 2, 3 and 4. So let me fill up the value 0, 1, 2, 3, 4. Column also I will fill it up as 0, 1, 2, 3 and 4. Now let us do the addition. Now start with 0. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 2 is 2. 0 plus 3 is 3. 0 plus 4 is 4. So one column we have finished. We'll start with the next. So 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5. But here it is mod 5. So this will become 0. Coming to the next column. 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. So 5 mod 5 is 0. 2 plus 4 is 6. So 6 mod 5 is 1. Next column with 3. 3 plus 0 is 3. 3 plus 1 is 4. 3 plus 2 is 5. So 5 mod 5 is 0. 3 plus 3 is 6. 6 mod 5 is 1. 3 plus 4 is 7. 7 mod 5 is 2. The last column now with the 4. 4 plus 0 is 4. 4 plus 1 is 5. So 5 mod 5 is 0. 4 plus 2 is 6. 6 mod 5 is 2. Sorry, it is 1 here. Yes, 6 mod 2 is 1. So let me write 1. Next is 4 plus 3 is 7. 7 mod 2 is 7 mod 5 is 2. And 4 plus 4 is 8. 8 mod 5 is 3. So we have done the entries for the table over here. So I will write the additive inverses here only. So additive inverse for, let me take the number as W and this additive inverse as minus W. So here this is additive inverse. So what is additive inverse? When we add to that number, we should get the sum to be 0. Let us see for what, when do we get 0? So for 0, when do we get 0? For 0, the additive inverse is 0. Now for 1, where do I get the entry 0? Against the 4 column. So for 1, what is additive inverse? Additive inverse is 4. Next come to 2. When I come to 2, where do I get 0 entry? In this particular. Okay, so what is the corresponding element? 3. So for 2, what is the additive inverse? 3. Next, for 3, where is the entry 0? At this. So what is the corresponding entry there? It is 2. So for 3, what is the additive inverse? 2. Next, 4. So when I see the entry here it is 0. What is the corresponding element? 1. So for 4, additive inverse is 1. So this is the way. First you have to build the table. Then we have to write the additive inverses. Now here let us do the multiplication table. So I'll write the multiplication symbol here. Then the entries. We know the values are 0, 1, 2, 3 and 4. Corresponding entries here 0, 1, 2, 3 and 4. Now let me multiply. So when you multiply with 0, we know that your answer is going to be 0 only. So I'll fill up the first column with the 0. Next is we have 1. 1 into 0 is 0, 1 into 1 is 1, 1 into 2 is 2, 1 into 3 is 3, 1 into 4 is 4. We'll come to the next column. 2 into 0 is 0, 2 into 1 is 2, now 2 into 2 is 4, 2 into 3 is how much? 6. So 6 mod 1 is how much? Sorry, 6 mod 5 is how much? It is 1. 4 2s are 8. So 8 mod 5 is 3. We come to the next column. So next column is over here is 3. So 3 into 0 is 0. 3 into 1 is 3. 3 2s are 6. 6 mod 5 is how much? 1. 3 3s are 9. So 3 mod 5 is 9 mod 5 is how much? 4. 3 4s are 12. 12 mod 5 is 2. So now coming to the last column. So 4 into 0 is 0. 4 into 1 is 4. 4 into 2 is 8. 8 mod 5 is 3. Next is 4 into 3 is 12. 12 mod 5 is 2. Next is 4 into 4. 4 into 4 is 16. 16 mod 5 is 1. So now we have done with the table entries. Now let us see the multiplicative inverse. So we have to write the multiplicative inverse. So let me write it here only. Multiplicative inverse. So I write here W and I write this as W inverse. So here when we have to check where we have the 1 as the entry. So for 1, multiplicative inverse is 1. For 2, I have 1 entry over here, corresponding entry is 3. So for 2, the multiplicative inverse is 3. For 3, where do I get 1 as entry? Corresponding entry is 2. So for 3, it is 2. Finally, for 4, we have an entry 1 over here. So for 4, what is this entry? Where do we get entry as 1? When I multiply with the 4. So for 4, multiplicative inverse will be 4. So this is the multiplication table and these are the multiplicative inverses. So now let us find the multiplicative inverse of a polynomial over here using the extended Euclidean algorithm method. So here the given polynomial is x to the power 7 plus x plus 1 mod of x to the power 8 plus x to the power 4 plus x cube plus x plus 1. So first let us find the GCD. So here how to find the GCD? We have to divide the polynomial x to the power 8 plus x to the power 4 plus x cube plus x plus 1 by x to the power 7 plus x plus 1. So let me just divide that. So let me just write the polynomial here. X to the power 7 plus x plus 1. Okay, and here I will write x to the power 8 plus x to the power 4 plus x cube plus x plus 1. So I need x to the power 8. So I will write x over here and multiply with the x to the power 7 plus x plus 1. So I get it as x to the power 8 plus x square plus x. So this is GF of root to the power 8 field. So here addition and subtraction both are same. So if I add also, it is going to be 2 mod 2, it is going to be 0. And if I subtract also, 1 minus 1 is going to be 0. So what is the remainder we get over here? X to the power 4 and plus x cube plus x square. X plus x is 2x. So 2 mod 2 is 0 and plus 1. So now we have to go to the next stage of division. So here before going to the next stage of division, let us write this. We are applying extended Euclidean algorithm. So here let me write it in the form of A is equal to quotient into B plus using the division algorithm. So we have to write it in this form. So x to the power 8 plus x to the power 4 plus x cube plus x plus 1. So this is your A equal to, so what is the quotient we got? The quotient what we got was x. So x into, and the multiplier, the divisor was x to the power 7 plus x plus 1 plus the remainder. So remainder is x to the power 4 plus x cube plus x square plus 1. So this is the remainder. So I can write this in the form of, now I want the remainder. So remainder x to the power 4 plus x cube plus x square plus 1 is equal to, now what is this? This is our A. And what is this? This is B. So we can write this as A minus B into x. You can write the whole thing. Just to simplify it, I am writing this in as A and B. Otherwise you have to write x to the power 8 plus x to the power 4 plus x cube plus x plus 1. So now we know this remainder. This remainder is nothing but R1. Okay, this is R1. So that is equal to A minus B x. So continuing in the next step, now we have to divide x to the power 7 plus x plus 1 by x to the power, the remainder, previous remainder, that is R1. So I will write the remainder. So remainder was x to the power 4 plus x cube plus x square plus 1. And here we have tried the b, x to the power 7 plus x plus 1. So I need x to the power 7. So what do I have to write? I have to write here x cube. So what do we get here? X cube into x to the power 4 is x to the power 7 plus x cube into x cube is x to the power 6 plus x cube into x square is x to the power 5 plus x cube into 1 is x cube. So let us add up addition and subtraction again. It's the same. So what do we get here? We get x to the power 6 plus x to the power 5 plus x cube plus x plus 1. So here I can still, this is still smaller than the x to the power 6. So I can further divide. So plus we take x square. So x to the power 6 plus x to the power 5 plus x to the power 4 plus x square. Again adding x to the power 6 and x to the power 6 to x to the power 6, that will be 0. X to the power 5 plus x to the power 5, again that is going to be 0. So what will be our remainder? So x to the power 4 plus x cube plus x square plus x plus 1. I can still further continue my division, so I just put plus 1. So what do we get over here? So we get it as x to the power 4 plus x cube plus x square plus 1. So what is the remainder? We get the remainder as x. So this is our remainder. So now let us write this also in the form of using the division algorithm. Now applying division algorithm, I can write it as x to the power 7 plus x plus 1 equal to x to the power 4 plus x cube plus x square plus 1 into x cube plus x square plus 1 plus x. Now next I wanted remainder is equal to, that is remainder is x equal to x to the power 7 plus x plus 1 minus x to the power 4 plus x cube plus x square plus 1 into x cube plus x square plus 1. So here what is x to the power 7 plus x plus 1? This is b. So I will write it as b minus, here this is the remainder r1. This is r1. So previously we know what is r1. r1 is a minus bx. So a minus bx into x cube plus x square plus 1. So here I can write it as b minus a into x cube plus x square plus 1 plus b into x to the power 4 plus x cube plus x. So equal to, so b, I can take b as common. So when I take it, so I get this as x to the power 4 plus x cube plus x plus 1 minus a into x cube plus x square plus 1. So here x equal to this is the value over here. So let us continue the next stage of division. So continuing with the division process. So here in the previous division, the remainder was x. So let us now we have to divide with x now. So x, and so here we have to write x to the power 4 plus x cube plus x square plus 1. So now here I have to write x cube. So what do you get over here? I get it as x to the power 4. So here x cube plus x square plus 1 plus x square. So this is x cube. Yes, here nothing. We don't have anything. It's just x cube over here. So x square plus 1 plus x. So here it is x square. So what is the remainder here? 1. So this is our remainder R3. So let me continue the next division process also. Now here I have to divide x by 1. So here I need x and x, so I get 0. Therefore, what is the GCD? GCD for this is 1. Therefore, we know that multiplicative inverse exists for this. So next, now we have to write this R3. Okay, we have to find what is the remainder. 1 is equal to. So x to the power 4 plus x cube plus x square plus 1 is equal to x into x cube plus x square plus x, okay, plus 1. So this 1 is equal to x to the power 4 plus x cube plus x square plus 1 minus x into x cube plus x square plus x. Now here we know that x to the power 4 plus x cube plus x square plus 1, this is remainder, okay, for R1. So what is this equal to? This was equal to a minus b into x minus, now here we know x also. What was x? X also we have previously got. So let me substitute that first. Let me write x cube plus x square plus x. So x was a remainder R2. So that also we know what it is. Let me just substitute for that as well. So it is b into x to the power 4 plus x cube plus x plus 1 minus a into x cube plus x square plus 1. So here let me just open up the brackets, a minus bx minus b into x to the power 4 plus x cube plus x plus 1 into x cube plus x square plus x plus a into x cube plus x square plus 1 into x cube plus x square plus x. So now we have to multiply all these terms and we have to find the answer. So here, so let us continue. A minus bx minus multiplying now b into, so x to the power 7 plus x to the power 6 plus x to the power 5 plus x to the power 6 plus x to the power 5 plus x to the power 4 plus x to the power 4 plus x cube plus x square plus x cube plus x square plus x. This is for b. Then for a, plus a into multiplying the coefficients of a, what do we get? X to the power 6 plus x to the power 5 plus x to the power 4 plus x to the power 5 plus x to the power 4 plus x cube plus x cube plus x square plus x. We get this. Now we have to see for the common terms. So here x to the power 6 and x to the power 6, x to the power 5 and x, because common terms in the sense why I am cancelling it is nothing but like x to the power 6 plus x to the power 6 is 2x to the power 6, 2 mod 2. So I get 0. X to the power 5 and x to the power 5. What do I get? 2 mod x to the power 5, which is again 2 mod 2, which is 0. Again, this x to the power 4 and this x to the power 4, I get it as 0. Then x cube and x cube, I get it as 0. X square plus x square, I get 2x square, so I get it as 0. That is why I cancelled it over here. Okay. It's not actually, I am not just subtracting it or so. Alright. Coming to this one here. It is mod, remember, it is 2 to the power 8 Galois field. So here 2x to the power 5 plus 2x to the power 5. 2x to the power 5 plus x to the power 5 is 2x to the power 5. So 2 mod 2 is 0. So again same thing is 2x to the power 4 is 0. 2x to the power 3 is again 0. Okay. So what do we get over here? So we get this as see a into, so we get here x to the power 6 plus x square plus x plus 1 when I take common terms. So I take minus b. So again I have over here x to the power 7 then plus x plus x. Okay, so this and this again, what do we get? 2x. So 2 mod 2 is 0. So finally we get this as x to the power 6 plus x square plus x plus 1 minus b into x to the power 7. So we get this as, so the multiplicative inverse is x to the power 7. So this is the answer. So this is how we have to work out the problem. Now here we have to find the multiplicative inverse of x to the power 6 plus x to the power 4 plus x plus 1 mod of x to the power 8 plus x to the power 4 plus x cube plus x plus 1 using extended Euclidean algorithm. So first what we have to do is the normal GCD finding procedure what we have done. So here first let us start with the division. So here we have to divide x to the power 8 by this. So let me just write x to the power 6 plus x to the power 4 plus x plus 1. Okay. And here x to the power 8 plus x to the power 4 plus x cube plus x plus 1. So here I need x to the power 2. So get x to the power 8 plus x to the power 6 plus x cube plus x square. Again remember this is GF of 2 to the power 8 field. So mod 2 operation here also is applicable. So what we get is x to the power 6 plus x to the power 4 plus x square plus x plus 1. So I can still further divide. So I'll plus 1. So we get this as x to the power 6 plus x to the power 4 plus x plus 1. So we get here x square is the remainder. So now let us write, this is our remainder R1. Using the division algorithm, we can write this as x to the power 8 plus x to the power 4 plus x cube plus x plus 1 is equal to x to the power 6 plus x to the power 4 plus x plus 1 into x square plus 1 plus x square. So what is x square equal to? So this is nothing but, we know it is a, and this is nothing but b. So I can write x square equal to a minus b into x square plus 1. So first stage of calculation is over. We'll go to the next stage. So let us continue with the division process. Now I have to divide with the previous remainder. Previous remainder is x square. So here we have to write x to the power 6, that is b, plus x to the power 4 plus x plus 1. So if I need x to the power 6, I need x to the power 4 over here. So we get x to the power 6. So what do we get? Remainder is x to the power 4 plus x plus 1. Again I can still further divide x square if I write x to the power 4. So what is the remainder? Remainder will be x plus 1. So now let us write over here. So in the using the remainder we want, what is the remainder? X plus 1 equal to. So let me write using the division algorithm, x to the power 6 plus x to the power 4 plus x plus 1 equal to x square into x to the power 4 plus x square plus x plus 1. Now, so x plus 1 will be equal to, what is this? This is b. We know that. So let it as b minus x square into x power 4 plus x square. But what is x square? X square was a remainder from the previous stage. So I can substitute for x square. So let me substitute. So b minus, so what is x square? So x square, we got it as a minus b into x square plus 1. This we know from the previous stage. Into x to the power 4 plus x square. So let me just open up the brackets. So b minus a into x to the power 4 plus x square plus b into x square plus 1 into x to the power 4 plus x square. So further if I simplify, b minus a into x to the power 4 plus x square plus b into x to the power 6 plus, you just open up the brackets, multiply, and you will get this x to the power 4 plus x square. So this and this again, why it can, and why I am cancelling it is nothing but 2x to the power 4. 2 mod 2 is equal to 0. Okay. So finally what do we get? We take the common terms together, x to the power 6 plus x square plus 1 minus a into x to the power 4 plus x square. So what is this? So x plus 1 is equal to b into x to the power 6 plus x square plus 1 minus a into x to the power 4 plus x square. So we'll continue with the next step. So let us continue with the division process. I have to divide x square by x plus 1. So x plus 1 and here it is x square. So what do I need here? X over here. X into x is x square. X into 1 is x. So x. So remainder is x. You can still further divide, not just take a 1. It's x plus 1. So what is the remainder? 1. Now further let me just continue the next step too. I have to divide x plus 1 with the 1. So I need x over here. X. What is the remainder? 1. So plus 1. 0. So what is the GCD? So this will be a GCD, the previous step. So GCD is 1. So now we know that multiplicative inverse exists. So now let us here. From this step we have to write. Okay. So what is x here? So x square is equal to x plus 1 into x plus 1 plus 1. Now from the previous stage we know what is x plus 1. No, first let me write. So 1 equal to x square minus x plus 1 into x plus 1. So from the previous stages we know what is x square, we know what is x plus 1. So what is x square? We got x square as a minus b into x square plus 1. And what is x plus 1? That we just got in the previous stage. So that we got it as b into x power 6 plus x square plus 1 minus a into x power 4 plus x square. Now let us just open up the brackets and simplify, and let us see what answer we are going to get. So here 1 is equal to, so I'm just going to open up the brackets. So a minus b into x square plus 1 minus x plus 1 into x to the power 6 plus x square plus 1 into b plus a into x to the power 4 plus x square into x plus 1. Further simplifying, a minus b into x square plus 1 minus, just let me multiply this. Just multiply each x with this and 1 with the other terms, and we'll see what you're going to get. This is x to the power 7 plus x cube plus x to the power 6 plus x square plus 1 plus a into, multiplying this as well, we get it as x to the power 5 plus x to the power 4 plus x cube plus x square. So equal to a into, so now common terms, let us take the a terms together, x to the power 5 plus x to the power 4 plus x cube plus x square plus 1, and the b terms together, and let me write it below, minus b into x to the power 7 plus x cube plus x to the power 6 plus x square plus 1 plus x square plus 1. So x square and x square, we get 2x square, so 2 more 2 0, 1 plus 1 is 2 more 2 is again 0. So finally we get this as a into x to the power 5 plus x to the power 4 plus x cube plus x square plus 1, and minus b into x to the power 7 plus x to the power 6 plus x cube plus x. So what is the multiplicative inverse? This is the multiplicative inverse. X to the power 7 plus x to the power 6 plus x cube plus x. Now here in this question, f of x and g of x, two polynomials are given where s is a set of integer. We have to find f of x plus g of x, f of x minus g of x, f of x into g of x, and f of x divided by g of x. So let us start with the first one, addition. So we have to add. So let me write x cube plus x square plus x, and add plus x square minus x plus 1. So what do we get when we add? I get it as x cube plus 2x square x, and this gets cancelled. So plus 1. Again see, this specifically they mentioned it is set of integer, so it is not GF field. So x square plus x square will be 2x square. We don't have to do any modulus operation. So this is the result for addition. Next is a subtraction. So f of x minus g of x. So f of x is x cube plus x square plus x minus of x square minus x plus 1. So x cube plus x square plus x minus x square plus x minus 1. So x square and x square will get cancelled. So the answer will be x cube plus 2x minus 1. So next we will see the multiplication. So let us multiply f of x into g of x. So here f of x is x cube plus x square plus x into x square minus x plus 1. So multiplying, I multiply x cube with all of the three terms, similar x square with all the terms and x with all the terms. So x cube into x square is x to the power 5 plus, sorry, it is minus here, minus x to the power 4 plus x cube. Next we start with x square, x to the power 4 minus x cube plus x square. Then multiply with x, so it will be plus x cube minus x square and this plus x. So x to the power 4 and x to the power 4 gets cancelled, x cube and x cube gets cancelled, x square and x square gets cancelled. Again I'll remind you, this is a simple polynomial arithmetic calculation. We are not using any field because they are clearly mentioned in the new question that it is a set of integer. 6 to the power 5 plus x cube plus x. This is the answer. Let us continue with the division. So we have to divide f of x by g of x. So here, so we know that f of x is x cube plus x square plus x and g of x is x square minus x plus 1. So I'll write x square minus x plus 1, and here I will write the f of x, x cube plus x square plus x. So I need a x over here. So I can write this x cube minus x square plus x. So again let me remind you, this is a simple polynomial division. No Galois field is involved over here as mentioned in the question. This is a set of integers. Get this as 2x square and this gets cancelled because plus minus. Okay, so I can further go ahead. So I'll plus 2. So I get this as 2x square minus 2x plus 2. So again minus plus minus. So I get this as 2x minus. So the answer is 2x minus